Hello students, I am your course instructor Professor Anisa Shikalgar. In previous video we have started with the finite automata. We have seen analytical definition and one simple example. There I told you also there are two types of the finite automata. One is the deterministic finite automata and another is the non-deterministic finite automata. So here we will see what is the difference and how to construct the DFA and how to construct the NFA. See here student, that is very important part because at each and every step while constructing the finite automata these rules are required. Okay, so here we know that in the definition of the finite automata there is a one tuple which is called as a delta. Okay, so delta is what? Transition function or mapping function. So the transition function for deterministic finite automata is q into summation, it goes to q. For example, here it is q0 on input 1, it goes to, suppose it is q1. Simply it is like that, the transition function for the deterministic finite automata. So here students, in non-deterministic finite automata, q into summation it goes to 2 raised to q, means q0, suppose on input 1, the same example I am taking because it will be easy to understand to you. q0 on input 1, it may goes to, suppose q0 also and it goes to 1 also. So what is the difference you understood student here? q0 on input 1, it goes to q1, right? Here that will be represented in the same way, and here q0 on input 1, it goes to q0 as represented over here and it goes to q1 also. So the students, what is the difference between DFA and NFA? In DFA, one input symbol, it goes to only one state. It should not go to another state in DFA. Okay, so if one transition of q0 it goes to q1, one from q0 it doesn't goes to any other state. Only one time a single input alphabet goes to the another state, that is about the deterministic finite automata. In NFA, if one goes to q0, there is also possibility that q1 from q0 it goes to q1. Again suppose I want 1 from q0 it goes to q2 also. So a single input alphabet it may goes to one or more states in NFA. Therefore we have written as a 2 raised to q, means on input alphabet one state it can reach to the more than one state also. So that is the basic difference for designing deterministic finite automata and for non-deterministic finite automata. Okay, so the students here we will consider one more example for understanding the difference between DFA and NFA. Suppose here these are the number of states 1, 2 and suppose 3 is the final state. Okay, suppose I am considering the deterministic finite automata. So here suppose input alphabet A is there. Summation, suppose it is A and B. So what is compulsory part for DFA, that I will show you in that particular diagram. So A and B, two input alphabets are there. 1, 2, 3, number of states are 3. So from 1 input alphabet it goes to 2. So what about the B input alphabet of 1? So it should goes to some another state or that particular state itself. Suppose B it goes to 1. So from 1 A and B both input alphabet goes to whatever another state or that state itself. So A and B, it is over. Then from 2 the next state is 2. From 2 also A should go to and B should go to some another state or that particular state itself. Suppose it is like this. Here it is B goes to 3 and there is a loop of A. So the 2 is also fulfilled the condition because A goes to that particular state and B goes to that. Then suppose here is a loop of A and B, add the 3. So students, now that particular diagram, here see that part, that particular diagram we can call as a DFA, because from 1 A and B goes, from 2 here it is also completed, from 3 A and B goes. Now it is called as a, it is called as a DFA. So for DFA it is compulsory that the whatever the input alphabets, all input alphabet, it should goes to the some another state or that particular state itself. Then the same rule is not applicable for NFA. That is only the difference. The first we have seen difference for the delta, and what is the another difference, so that particular about the diagram. That is the rule which is applicable for DFA. The same rule is only not applicable for NFA. Means what? Suppose from 1 A goes to 2 and I don't want to give the B transition to any other state. So it is okay with respect to non-deterministic finite automata. Also from 2 B input goes to 3 and I don't want to give the A input alphabet to any of the state. It is also okay. So that particular, also 3 we have given A and B. I don't want to give the loop also. So here that particular diagram, it is called as a NFA. But it is not called as a DFA because it don't cover the rules of the construction of DFA. So here these are the two important rules which are necessary for the constructions of the DFA and NFA. See students, there are most of the examples in which one particular statement is given. Design the DFA or design the NFA. If you know the basic rules of the designing DFA and NFA, then only you can move forward. Okay. So if don't know the basic rules, then there is no what we can say, you can't design the DFA and NFA also. Okay. So here what is the rule for designing DFA? Q into summation, it goes to Q, means at a one symbol it goes to only one state. Another is here whatever the input symbols are there, both should goes to some other state or that state itself. That is regarding the DFA. Then NFA, Q into summation, it goes to 2 raised to Q, means on one input symbol it can goes to more than one state also. And another, which rule we have applied for DFA, that is not applicable, means suppose A goes but from 1 B didn't reach any other state, it is also okay. So these are the rules for designing the DFA and NFA. In next video, we will actually start with the construction of DFA. First I will take the construction of DFA and then we'll move towards the construction of NFA. So the students, here we have seen the difference for DFA and NFA. So what do you think, which finite automata is easy to design? Okay, so I want your what answer of that particular question, which is the simpler to design. What do you think, DFA or NFA? So the students, NFA is simpler to design because these rules are not applicable. So we can easily construct the non-deterministic finite automata whenever any kind of regular language is given. So that is also one difference part, that non-deterministic finite automata is easy to construct, and also the less number of states. Suppose here one particular language is there, one regular language is there, suppose that language if I design by using 3 number of states, Q0, Q1, Q2, then the same language we can design by using only 2 states in the non-deterministic finite automata. So minimum number of states we can apply for the non-deterministic finite automata. And the another difference is it is more powerful than the DFA. So the students, here I have told you the 3 basic differences. What are those? First is the NFA is more powerful than the DFA. Again, NFA is easy to construct because less number of states are required in the non-deterministic finite automata. So that is the differentiative part of the DFA and NFA. In the next video, I will start start with the construction of the deterministic finite automata. Okay, thank you students.